Before using the single crystal street probe to detect the workpiece, it's necessary to make a curve that assesses the defect size. The specific steps to this curve are as follows. The probe parameters are entered into the instrument. According to the street probe calibration method and calibrated. Press DAC AVG key. Select DAC. OK to set the maximum depth to target reflection hole to 30 mm. Diameter is set to 5 mm. Press F5 to continue. At this point, the instrument in the upper right corner of the waveform display area make DAC worse on behalf of the curve has been made into the state, and begin to find the first measurement points. Place the street probe on the plate contrast test block. Aim at depth of 10 mm hole and find its highest wave. Press Auto Gain to make the echo height reach 80% of the screen. Press F5 to record the first measuring point. Next, align the street probe with a hole with a depth of 20 mm. Use the gate to lock its highest wave. Press F5 to record the second measurement point, and then align the street probe to a hole with a depth of 30 mm. Using the gate to lock its highest wave. Press F5 to record the third measuring point. Press F1 to finish recording the measurement point. Press F5 to save. Next, according to the actual measurement needs. To set the surface compensation value or experience value. The workpiece thickness is set to the actual sheet thickness value. Press F5 to confirm. In the detection standard setting, will be sentenced line, quantitative line, rating line is set to 0 dB. Press F5 to confirm, then the distance velocity curve has been completed. We use this curve as the benchmark sensitivity for sheet metal testing. Before using the dual crystal street probe to defect the workpiece, we need to adjust the probe zero adjustment and sensitivity. Proceed as follows. Press the adjustment key, turn the shutter wheel to probe type, probe frequency, chip size is set correctly, the probe placed in the same thickness with the plate on the ladder test block. Press the sound pass key, rotate the rotary wheel to adjust the detection range. Press the gate key, turn the spin wheel to adjust the gate start. The gate locks the first echo. Move the probe. To find the first wave of the first wave, press the adjustment key. Select the zero bias, rotating the rotary wheel to adjust the probe zero bias. So that the highest wave in the device on the display depth. Just with the probe at this time contact with the workpiece thickness. Then double crystal probe calibration is completed. Press the gain key to rotate the rotary knob to adjust the basic gain. So that the first bottom wave drops to 50% of full scale. And then rotate the rotary knob to adjust the basic gain, increasing the 10 dB as reference sensitivity. After calibration and sensitivity adjustment of the equipment can be used for thin plate detection. Next two cases, reflective wave can be judged as defect wave. Defects the first reflect wave amplitude is higher than the amplitude distance curve as shown on the screen. Is used to detect a plate less than or equal to 20 mm. The first reflect wave amplitude is greater than or equal to 15% of the full scale of the display. As shown on the screen, this reflect wave. The first reflected wave amplitude is less than 50% of the full scale of the display as shown on the screen. This wave is a defect wave. Here's how to quantify the identified defects. How to use a straight probe to determine the boundary or indication length of the defect. When the board thickness is less than or equal to 20 mm, the moving probe causes the defective wave to drop to 50% of the full scale under the reference sensitivity condition. The probe center point is the boundary point of the defective wave, as shown on the screen. When the thickness is greater than 20 mm, less than 60 mm, the moving probe to the defect wave down to the distance amplitude curve. The probe center point is the defect point. As shown on the screen, this wave is the boundary point for the case where the first reflected wave amplitude below the full scale is 50% of the full scale. The moving probe causes the first reflected wave to raise to 50% of the full scale of the display under the reference sensitivity condition or to the distance amplitude curve. Then the probe center point is boundary point of the defect. How to use a straight probe to determine the boundary of the defect or indicate the length. After the boundary area of the defect is determined, the long side is the length of the defect, and the rectangular area is the indicated area of the defect. We will also introduce to the plate detection of another process, multiple back wave method. In the flaw detection, it's easy to find defective waves, this time only by observing the attenuation or disappearance of multiple bottom waves to determine the defects. Steps of detecting the plate by multiple bottom wave methods are as follows. After calibrating the straight probe, press the sound pass key to adjust the detection range to more than 5 times the thickness as shown. Determine the reference sensitivity. Press the gate key. Adjust the gate start to lock the fifth bottom wave. Press the gain key. Adjust the basic gain so that the fifth bottom wave height of 50% of full scale. Determine the defect. Observe the fifth bottom wave. Amplitude below 50% to determine the defect. Determine the defect range. Move the probe. When the fifth bottom wave down to 25% of full scale, the probe center for the defect boundary point